Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
Now, remember, once database is built, once database has been created, LSDB, then router will always think that I am a central point. I am a root. I am a root, kind of root bridge. I am a root. Guys, try to understand.
Yeah.
Because in OSPF, all routers will be responsible to elect their best path independently. No one will inform to their neighbor that okay, this is your best path. Never. They will exchange their database only. So this time in OSPF there is a rule that after maintaining LSDB, link state database, they will run SPF algorithm onto it now. SPF is what? Shortest path first algorithm. And then it will create SPT, shortest path tree. And it will assume itself as a root now. And then accordingly it will create that SPT, shortest path tree. Are you getting my point or not?
Yeah.
See, router will assume that it is a root. And by assuming itself as a root, then it will create SPT, shortest path tree. And best routes will get installed inside its own routing table. And you see, if you configure this command on our one show IP protocol, gateway of information sources, in distance vector routing protocol, you will always find your neighbors only under this option, routing information sources. Under routing information sources in all distance vector routing protocol, you will always find only and only neighbors. But in OSPF, because you do not depend on that information which is given by neighbors. Here, it is getting this information individually from each router. It is getting this router LSA from each router, and then independently it is responsible to elect its best path. Are you getting my point or not? So here it is not showing you only neighbor. Whereas in distance vector routing protocol, it will always show you that okay, the source of information is what? Neighbor only. But this time, of course, it is not gonna to show you that okay, routing information source is just your neighbor. Never. Because neighbor is not your, this time in linked state routing protocol, it is not depending on that information which is given by its neighbor. Even you can see that no one modified anything existing any LSA. No one modified anything in existing LSAs. Have anyone modified any LSA? Like if LSA is generated by R1 have given that its own router LSA to its neighbor R2. R2 have not made any change in it. And without changing this LSA, without modifying, it will advertise that LSA towards its another neighbor. So remember that in OSPF, routers will exchange their LSAs without modifying them. They cannot perform any type of modification. That is why R1 is saying that okay, the LSA of R5 is given by R5 itself. It is not showing you that okay, it is given by R1. Or sorry, it is given by R2. Because R2 is not providing it to R1. R2 is just doing what? Like R2 got it from R3, but actually R3 got it from R4 and R4 got it from R5. And without doing any modification in that LSA, they are giving it to their neighbors. That is why here we are saying that it is a fully linked state routing protocol. If it is not happening, if it is not happening like that, if it does not perform like that, who will say it that okay, this is a linked state routing protocol or this is a fully linked state routing protocol? Are you getting my point or not?
Yes.
Have you understood it completely? Fine. Let me do one thing now. I'm going back again on R1 and I'll say no router OSPF1 so that it will remove the whole database. R2 will also break its neighbor shape. Shut it down. Understood? Fine. Now I'm gonna to capture this link. Let me show you debug. Now shut down. And then after I will enable OSPF on R1. Area 0. Now you see neighborship have came up now. Done. Fine. Let me stop it now. See, this hello is generated by R1 first. In this hello, as I said that first, in all type of packet, whether it is hello, LSR, sorry, DBD, LSR, LSU or LSAC, in all types of packets, first 24 bytes will remain same. That is also known as OSPF header. So I have opened this hello packet now. Inside this hello packet, this is your OSPF header, and this is always gonna to be same in all. And I told you that this hello packet will be having version, type, length, source router, area ID, packet checksum, type, and authentication data. But by default your authentication type is what? Null. That is why it is showing you here null. Any problem? Are you okay with it? Fine. This is the information contained by OSPF header. Then you can open this hello packet. This information is contained by hello packet. Network mask, as I said, subnet mask must match. That is why hello packet is responsible to contain your network mask information as well. Hello interval, your option bits, if it is an SSA, not an SSA, or whatever it is, you understand? So all these things are there. Priority is by default 1. Dead interval is what? 4 seconds. Is there any DR? No. Is there any BDR? No. Are you getting my point or not? Fine. Then after you can see the hello packet generated by R2. This is also multicasted with using .5. Active neighbor. This is generated by R2.
पैकेट लंथ 48 है। ये सिर्फ हेडर की बता रहे हैं
पूरे पैकेट मतलब OSPF की जो इन्फॉर्मेशन है उसकी बता रहे हैं। टोटल लेंथ तो आईपी हेडर के अंदर होगी ना, वो इसके ऊपर है आईपी हेडर के अंदर, यहाँ पे हो गया ना 80। See, the hello packet generated by R2 is containing its neighbor router ID. So once R1 will receive it, will move into two-way, because R1 will get its own router ID inside received hello packets. Fine. So here you can see that active neighbor is 1.1.1, and then after once it moved into two-way state, it have immediately generated. See, R1 received hello packet from there, and again it have generated one hello packet as well as DB packet. See, the first DB packet will be blank. It will be blank because it will be used for those DB packets to elect your master slave. It means that in X start state also they will exchange DB packets. Generally we says that DBD messages will be exchanged during exchange state only. No, during start state 2 they will exchange their DB packets, but those DB packets will be empty DB packets, just to perform election of master and slave and to negotiate sequence number of DBD packets. Leo, try to understand it, right? So this time this R1 have generated a DB packet as well as, because just now for R1 neighborship moved into two-way state, right? And after 2-way it has put it into access start state now. So at same moment it has generated this hello as well as this DB packet. So this hello packet is containing the active neighbor's IP address, which will be this time 22222. So that R2 will also move into two-way state. Are you getting my point or not?
Yes.
That is why R2 have also generated now DB packet. Fine. Let's open that DB packet which is generated by R1. This is. Open it. And this is your DB packet. Type is what? 2. Hello.
Yes.
This is OSPF header. It will be common for all. Is not it? Then after it, let's open this DBD. See, this R1 said that okay, let's start our sequence numbers of DBD packets from 4905. Hello. It can, I mean, routers can pick any random value. So this time they have said that okay, DD sequence, let's start this DD sequence number from 4905. I will also let you know that why this sequence number is mandatory, is compulsory for DBD packets. Are you getting my point or not?
Yes.
Great. Now inside DB description, M means, I means this is the very first DB packet generated by this router. This I bit specifies that this is very first DB packet generated by this router. This M bit, more bit, says that it is also having some more DB packets. This is not the last DB packet. Then MS bit, it is saying that I am master. If MS bit is 1, it means it is saying that I am master, because both of them will specify that they are master. Are you getting my point or not?
Yes.
So this DB packet is generated by, tell me, R1, and MTU's information is also contained by this DB packet. Fine. Then next DB packet is generated by R2. This DB packet is generated by R2. It will also say the same thing, that okay, this is the init, very first DB packet generated by this router. It is also saying that okay, some more DB packets are to be follow, and it is also saying that I am master, but any one of them will be elected as master, either R1 or then first of all they will compare their priorities they have already exchanged in hello packets. Then they will compare their router IDs. They already have their router IDs. They already have each other's router ID, so they can elect master and slave very easily. And it has said that okay, sequence number is what, 6176. So which one will be winner? Of course R2. So this is generated by R1 now. Next DB packet has been generated by R1, and see, in this DB packet it will say that I am not a master, and also I will be using your sequence number. I'm negotiating that I accept your sequence number. Hello.
Yes, sir.
Wow, great. Priority is by default and higher router ID.
सीक्वेंस नंबर जो होता है उसके बेस पे नहीं बनता.
Nope.
मैंने देखा है इसका मतलब ज़्यादा होता है, पता नहीं कम होता है, हमेशा ज़्यादातर वही होता है.
No, I said whoever will be having higher sequence number, I mean the DRC, actually master sequence number would be negotiated. It doesn't matter whether it is higher or lower. This is generated by now R2. Next packet. See, okay, first of all, let's see.
Not the slave thing.
Wait. MS bit is now clear.
0.
Means it is not a master. And it have also negotiated sequence number. See, 6176 given by R2. It does not have any other. See, more bit is not set now. What does it mean? That it does not have any other DB packets now. Are you getting my point or not?
Yes.
Fine. It have specified that it does not have any other DB packet now. And you know why have it shown you, or why is it saying that okay, I don't have any DB packet? Because it was not having any LSA available inside its own database table except its own LSA.
Yeah.
And remember that if router is having only and only its own router LSA, then it will never inform to its neighbor that okay, I'm having this LSA, because this is predefined that of course neighbor is having its own router LSA. Are you not getting my point? Let's say me and Ujjwal, we both are going to form OSPF neighborship now. So I will never inform to Ujjwal that okay, I'm having this router LSA, because this is predefined that Ujjwal must know it that at least I will be having my own router LSA in my database table. Because he is going to form neighborship with me, so at least he must be having my LSA.
Yeah.
So because R1 was not having any LSA inside its own LSDB, are you getting my point or not? Because I just enabled OSPF on R1, it was having its own router LSA only.
Yes. So जब आपने पहले दिखाया था तो उसमें भी 1 बिट थी ना.
हाँ.
उसके अंदर भी तो वो जो R1 है.
हाँ.
तो ये बोलेगा ना कि भाई.
अरे तो तब तक मास्टर स्लेव इलेक्शन तो नहीं हुआ था ना, नेगोशिएट भी नहीं हुआ था सीक्वेंस नंबर. Fine. And now it is giving this DBD to R2, and then R2 will be responsible to generate it now. See, R2 have generated this DB packet now. See, this is. And in this DB packet, let me show you OSPF DB description, sequence number 61, which is the next sequence number this time, because whenever master will generate next DD. See, let me explain you the uses of sequence number for DBD in OSPF. Try to understand. We are having LSEC, external acknowledgement, but only for updates, LSU. Do we have any LSEC for DBD packets? Try to understand my point. Do we have any kind of acknowledgement for DBD packets in OSPF? Are we using TCP for OSPF? So in case if DBD lost somewhere in the network, how will you come to know that okay, it was not delivered? So for that purpose, here in OSPF we are having sequence number for DBD packets. What happens? Let's say this is R1, this is R2. Now this is master, let's say, and this is what? Slave. So let's say they have negotiated with sequence number 10. So whenever, because master will be responsible to send DBD first now, is not it? So this master will send DBD packets with sequence number, let's say 10. So now it is mandatory that whenever a slave will receive any DB packets with any sequence number coming from master, it has to give response back. Rejuvi. Sorry? Okay, meditation. You have very strong meditation. Good. And you are doing meditation inside the classroom. Great. So R2 will send a DBD back to R1 in the response of received DB packets coming from R1, but with the same sequence number. And it doesn't matter whether R2 is having any information to provide to R1 or not, doesn't matter. But if slave have received any DB packet coming from master, slave has to respond back. Doesn't matter whether it is having an information to give to master or not, but it has to respond with DB packet with same sequence number. If slave do not have any information to provide to master, then slave will send a blank DBD but with the same sequence number which was received from master. So this time R2 is gonna to send this DBD back to R1 with same sequence number. So once this master will receive this DBD coming from slave with the same sequence number, it means it will get confirmed that the DBD generated by R1 has been delivered successfully on master, on slave. Then if master is having some more information to provide to slave, then master will send another DBD but with higher sequence number this time. Then R2 has to respond back once again. Does not matter whether R2 is having information to provide to master or not, but it has to give response with DBD with same sequence number. So DBD once again and with same sequence number 11. Now there can be a different thing as well. How? For an example, let's say this is R1 and this is R2. This is master and this is what? Slave. But this slave is having a huge database. Are you getting my point or not? This slave is having a huge database. So let's say master was having only one LSA. So now master will send first DBD in which it have given that information to slave with sequence number, let's say 10. Now slave have to give DBD back to master with sequence number, with same sequence number. And let's say that it was not possible for slave to explain, to describe its entire LSDB within a single DBD packet. Fine. So now how will it be possible for slave to send other DB packets in the direction of R1? Because slave can send DBD packet in the response of that DBD packet which is coming from master only. It cannot generate it from its own end. Are you getting my point or not? See, slave do not have that authority, that capability to generate DB packets by its own. It can generate DB packets in the response of that DB packet which is generated by master only.
They set the mode bit and center.
Exactly. See what will happen now, that if slave is having some more information to provide to master, then it will set more bit here with same sequence number. Now when this master will receive it, it will receive this DB packet with sequence number 10. It means the DB packet generated by master have delivered onto slave, but it have received this DBD coming from slave with more bit. It means that slave is also having some more information now. So this time, because master do not have anything else to provide to slave, but it is mandatory, it is compulsory for master now to send another DBD with higher sequence number, and it could be anything. I mean, it can be blank DBD as well. So with higher sequence number. So now R2, I mean the slave, you understand, will send another DBD with the same sequence number, and if it is still having some more information to provide, then again M bit will be 1, more bit will be 1. Are you getting my point or not? In same manner, master can also have some more information as compared to slave. So whoever will be having some more information, then they will always use M bit, more bit, to inform to their neighbor that I'm still having some more information to provide. The same thing is happening here. Like this time this DBD is generated by, see, when last DBD was generated by R1, right? And in that DBD it is specified that it does not have any more DBD, because we saw that it was having M bit as 0. Are you getting my point or not? Yes. See, this is generated by R2, but it was generated by R1. So in it was having M bit as 0. Now it is generated by R2. R2 is having this And indeed C, as I said, that DB will be responsible to take your LSA headers. So what is that? So R2 was having 5 router LSAs in its database table, because R2 will see OSPF keeps your LSA for 60 minutes in its LSDB. So R2, and here there is no rule of split horizon as well. So R2 was having LSA generated by R1 as well in its database table. So when they formed neighborship, then R2 informed to R1 as well that I'm also having the LSA generated by 1.1.1.1, but R1 is not gonna accept it. R1 will not accept it because it will be old, its checksum will be different, might be sequence number can be higher, and might be R1 sequence number is what? Lower, but due to time and checksum, R1 will identify that okay, this LSA is what? Older LSA, old LSA. So I should not accept this LSA because R2 is C. Guys, try to understand. Previously R1 and R2, both of them were having neighborship, is not it? Fine. R2 was having the router LSA generated by R1 in its database table. Then what I did, I removed OSPF from R1. So R1 removed its own database. But did I remove anything from R2? R2 was still having the LSA generated by R1, right? Because routers will always keep your LSAs inside their database table for 60 minutes. Refresh interval is 30 minutes. So they will send periodic updates after every 30 minutes. But they can keep your LSA inside their database table up to 60 minutes. Are you getting my point or not?
Yes.
That's okay. That is why when R2 given its DB packet to R1, it included all LSAs in that DBD which were available inside the database table of R2. See, 2, 3, 4, 5. Oh, okay. Actually, R1, it means okay. It didn't provide the header of that LSA which was down actually, because it was down, right? But it still R2 was having 5 LSAs because network LSA was also there. Hello.
Yes, sir.
Network LSA was also there. However, it should have given only 4 LSAs information, 4 LSAs header, but it was having 5 LSAs. Network LSA was also there. That is why total number of LSA headers are 5. And inside this DB description, see, mbit is what? On. It means
More.
yes, more bit. It means it is having some more DB packets. Fine. Now R1 received it and R1 regenerate its DB packet with the same sequence number which came from, see, and it does not have anything in it. Does it have? So this is blank DBD. It does not have any LSA's information in it. Then R2 have again generated this DB packet, but this time mbit will be 0. This time mbit will be 0 because now R2 is not having anything to tell to R1, because R2 have already given its whole information to R1 now. Hello.
Yes, sir.
With higher 6178. Now slave will come to know that there is no other DB packet, right? Slave. That is why it have generated, tell me, LSR, link state request. So R1 was not having any LSA inside its own database table, right? Was it having? No. So inside this request it will specify all that, all that advertisement ID and the link ID for which it wants LSA, for which it wants information. Hello. So R1 received LSA headers given by R2 for all those 5 LSAs, and R1 was not having any one of them because I removed the complete database of R1. So in this LSR you will be having all that complete information. See, 5 LSR inside a single packet because it was not having any LSA's information inside its own database table. And that is why it is good feature in OSPF that they keep LSAs inside their database table for next 60 minutes. In case if neighborship goes down, then next time whenever neighborship will come up, they will not require to send too much updates to each other.
Yes.
So it will compare its database after receiving DB packets. If it finds that okay, I'm already having complete database, only some information is missing, then it will send a request to its neighbor to send that small information only, not for entire information, not for entire updates. But very first time it has to give all updates. That is why this R1 have generated LSR for all LSAs. See, and in this LSR it is having type, link ID and advertising ID in all. See, this is network LSA.
Yeah.
It's not it. So this is all about LSR. Now this LSR will be received by
R1.
okay, R1 have also generated this DB packet as well, because it received that DB packet came from, because if slave receives any DB packet from master, it has to give the response, right?
Same thing.
See, with the same sequence number, but it does not have anything in. Is not it? Then after it, see, R2 received LSR.
So we are in loading state. Huh?
Yes, now you are in loading state. Because during exchange state, they have exchanged their DB packets. Inside DB packets, you are having the LSA headers.
Yeah.
And when it have sent LSR, and now they are giving LSU, see, so it is loading state.
Loading state.
It is also multicasted. See, all packets are multicasted.
Yes.
Even LSR.
तो रिक्वेस्ट पर्टिकुलर एक कर रहे हैं ना,
So what?
तो मल्टीकास्ट करेगा.
By default. See, in update also, the header, OSPF header is common, same as other packets, but it is having now, see, LSAs, complete LSA, not LSA header.
Even we can find VE.
Exactly, everything. See, let me show you. LS type. This is router LSA. Who taught you CCNP?
Ajay Paul.
LS type router LSA. You understand? LS edge is what? Do not edge is not there. And this router LSA is generated by 2222. You see, and it is having how many links information?
4 links.
Four links information. And these links are, see, it's not it. Then it is also having one another LSA which is generated by, see, R3. Right now it is not the endpoint of virtual link, it is not the SBR, and also it is not a border router. These are 3. Generated by R5 also. So this is the only thing that you were having in the database table of R1. So that is given by, see, in the form of LS U. And then in the response of LS update, you see R1 also have given, see, R2 have not generated any LSR to R1, because R1 didn't tell to R2 that okay, I'm having this LSA inside DB packets. But again R1 have to send update it at its own router LSA to its neighbor, right? So you see R1 have given it, see, its own router LSA. It's not it, in which it is specified that I'm also connected with point-to-point neighbor 22222, and what is the cost to reach it? 64. Now it came to know, R2 came to know that okay, on this segment I'm also having one other point-to-point neighbor, right? So now it have generated one another update, but in this update it will not be having a complete, all router LSS. In this update it will not specify all router LSS because this point to point has been added in the router LSA of R2 only. So the sequence number of router LSA of R2 have been incremented by 1 after knowing that okay, there is a router, point to point router, and the neighbor's router ID is this. So it will add that entry inside its own router LSA, so that what I said, that whenever there will be any change inside your router LSA, its sequence number will be incremented by 1 and it will immediately inform to its neighbor in the form of LSU. So this time this R2 have generated another router LSAC, another update, but in this update it will not be having all router LSAs. It is having only one router LSA, see, generated by R2 only, and this time it have also added this entry point to point with R1. And finally add acknowledgement generated by R1 as well as R2. Inside ls acknowledgement it is sending headers of all received LSAs. Hello. In ls acknowledgement, see, this is what acknowledgement type 5. It is having headers of all LSAs that it is having, not received, that it is having inside its own database table. So it is having now 6 LSAs, one network LSA and 5 routers are participating. So 6 headers are there. Are you getting my point or not? So inside header, see, only sequence number, advertising ID, linkage state ID, ls edge, checksum, all these things. Sequence number is not it. So it has given this acknowledgement to R2 and R2 have also given this acknowledgement to R1. And see, because R2 received only this information from R1. Understood? So this is OSPF neighborship states and this is the role of their packet.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.